Hello everyone, today we're going to be solving Aqa Gcse Chemistry Foundation Tier Paper 2, June 2021. This is a part 2 of the question paper where we're going to be solving from question number 6 to question number 10. Potash alum is a chemical compound. Potash alum contains potassium ions, aluminium ions, and sulfate ions. Which two methods can be used to identify the presence of potassium ions and potash alum solution? So since potash and alum, two metals occur together, if we do a direct flame test, then the color that it will produce will be a mixture of color. So to detect the potassium and aluminium, first we will do a flame test. Then we are going to do a flame emission spectroscopy on that particular flame test. Sodium hydroxide solution is used to test for some metal ions. Sodium hydroxide solution is added to a solution of potassium alum until precipitate forms. Complete the answer from the box. The color of the precipitate will be white because aluminium precipitate with sodium hydroxide, the color is white. Choose the answer from the box. Sulfate ions can be identified using dilute hydrochloric acid. The test for sulfate ions is done with hydrochloric acid along with barium chloride. So along with barium chloride solution. A solution of potash alum has a concentration of 258 gram per dm3. Calculate the mass of potash alum needed to make 800 cm3 of a solution of potash alum with a concentration of 258 gram per dm3. Give your answer to three significant figures. At first, we will need to convert the 800 cm3 into dm3. To do that, we're going to divide the 800 by 1000. Then, once we get the volume 0.8, we're going to find the mass that is needed for 0.8 dm3. So, since we know that it requires a concentration of 258 gram per dm3, so we're going to multiply 0.8 with 258. That will give us an answer of 206.4 grams. So, that will be the amount of potash alum that we will need to make that particular 258 gram per dm3 solution. Since our answer needs to be done in three significant figures, so we will say 206 grams. This question is about organic compounds. Butane is an alkane with small molecules. Choose the answer from the box. Butane can be used as a fuel. Typically, we use butane for household cooking as a household cooking gas. Polypropene is a polymer. What is the name of the monomer used to produce polypropene? So the name is within the molecule, which is propene. Ethene and steam react to produce ethanol. The equation for the reversible reaction is ethene plus steam producing ethanol. The reaction produces a maximum theoretical mass of 400 kg of ethanol from 243 grams of ethene and 150 kilograms of steam. A company produces 380 kilograms of ethanol from 243 grams of ethene and 157 kilograms of steam. Or they are supposed to produce 400 kilograms, but instead they could only produce 380 kilograms. The percentage yield of ethanol is less than 100. So we are asked to calculate the percentage yield of the ethanol. So we're going to say percentage yield. So we calculated percentage yield of ethanol, 380 divided by 400. This is the what we actually received, 380, and 400 is the theoretical mass that we're supposed to achieve. And then we multiply it by 100%, which gives us 95%. What are the two possible reasons why the percentage yield of ethanol is less than 100%? Because this particular reaction is reversible. So some ethanol can again turn back into ethene and steam, which is a very legit. That's one of the things. The other one is the apparatus, leaks. Then some ethanol may escape from the apparatus, which they couldn't trap. Ethanol burns in oxygen. Balance the equation for the reaction. So ethanol, we will count the oxygen on the right hand side. So there are 3 oxygen here, plus there are 4 oxygen here. There is 1 oxygen here already present. So we will require a total of 7 minus 1, 6. Because it is O2, so we're going to divide the 6 with 2. That gives us 3. Two processes for producing ethanol: fermentation and hydration of ethene with steam. This one we just studied a few moments ago. Fermentation is the process by using fungi. Raw material, sugar, energy use is low, slow, and purity is only 15%. Raw material is crude oil in hydration. The energy usage is very high and it is fast, and purity is 98%. Give two advantages and two disadvantages of using fermentation to produce ethanol. So when it comes to advantage, first of all, we can say fermentation uses lower amount of energy. Fermentation uses renewable raw materials such as sugar. However, disadvantage would be fermentation produces impure ethanol, which is only a very small percentage, like 15%. And the rate of reaction is very slow, so it takes a long amount of time to produce ethanol. This question is about fuels and energy. Figure 6 shows the percentage of electricity generated in the UK between 2007 and 2017 using oil and solar energy. Describe the changes in the percentage of electricity generated in UK between 2007 and 2017 using oil and solar energy. We can see that the uses of oil, it slowly and gradually decreases. It goes from a level where it was 1.3 to it goes to 0.6. No, finally it goes to 0.5 in 2017. And uses of solar energy has increased from less than 0.1% to 3.4%. So the answer can be written as follows. Uses of oil has decreased by 0.8% from 1.3 to 0.5% from 2007 to 2017. Uses of solar energy has increased by 3.4% from 0% to 3.4% from 2007 to 2017. Since this particular question says to describe the changes, the further additional points that we can write, there is no change in oil use between 2013 and 2015, and there is a slight increase in oil use between 2007 and 2009, and there is no change in solar energy use between 2007 and 2009. Use of solar energy increased mostly between 2013 and 2015. Oil contains carbon and some sulfur. When oil is burned, the product of combustion may be released into the atmosphere. Explain the environmental effects of releasing the products of combustion into the atmosphere. When oil is burned, carbon dioxide is produced, which is a greenhouse gas. Therefore, the surface temperature of the earth increases, which leads to global warming and can change climate. When sulfur is burned, it produces sulfur dioxide, which causes acid rain, and the acid rain can bring about damages to buildings, statues. It can damage trees, aquatic animals, and respiratory problem can occur in humans. Incomplete combustion of fossil fuel leads to the production of carbon, which is like a soot material, alright? They're particulates, and they can lead to global dimming and respiratory problem in humans. Carbon monoxide used during incomplete combustion is highly toxic and can damage hemoglobin. So just one reason why using solar energy is more sustainable way of generating electricity than burning oil. Solar energy is a renewable source of energy, so it does not require any input of fossil fuel. Solar energy may not be able to replace the generation of electricity from fossil fuels completely. Suggest two reasons why. The sunshine is unreliable and there can be increased demand for energy, and there is not enough space to actually put all the solar panels that will be needed to meet the demand for electricity from solar energy. This question is about alkenes. Table 6 shows information about some alkenes. Number of carbon atoms in the alkene molecule and its boiling point is represented. So when the number of carbon atom is 6, the boiling point is 69. When the number of carbon atom is 8, the boiling point is 126. We can assume that for X, the boiling point will be somewhere in 90s range. The way we find it out is from here to here, it increases nearly by 30 or 33. So from here to here, it can have a similar change. Plot the data from table 6 on figure 7. Predict the boiling point of X of the alkane with 7 carbon atoms in the molecule. So we will extrapolate at 7 carbons, and then we're gonna find the level. So it comes about 92. Figure 7 is not suitable to show the boiling point of alkene with 3 carbon atoms in a molecule. Suggest a reason why. The boiling point of 3 carbon containing alkane will be lower than 0, and figure 7 does not have values below 0. What is the state at 20 degrees Celsius of the alkane with 4 carbon atoms in a molecule? So 4 carbon atoms in a molecule at 20 degrees Celsius is going to be a gas, because the boiling point of 4 carbon atoms in a molecule, it's 0 degrees Celsius. So above 0 degrees Celsius is going to be a gas. The alkane with 9 carbon atoms in a molecule is called nonane. Complete the formula for nonane. Since they are saying alkane has a general formula H2N plus 2. So 9 times 2 plus 2 will be 20. So C9H20. Nonane will condense lower in a fractionating column during the fractional distillation, other than alkenes in table 6. You should refer to the temperature gradient in the fractionating column. Nonane has a higher boiling point, so nonane condenses where the column has a higher temperature. So as a result, it will condense sooner. This question is about paper chromatography. Food coloring contains a dye. Plan an investigation to determine the RF value for the dye in this food coloring. RF is calculated by the formula distance moved by the substance divided by distance moved by the solvent. Our plan should include a beaker, solvent, and a chromatography paper. So at first, we're going to draw a pencil start line on the chromatography paper and then place spot of the food coloring on the start line. We are going to use a solvent, for example, water if the food coloring, since the food coloring is water soluble, so we're going to use the solvent water and place the solvent in a beaker and place the chromatography paper in the beaker. But make sure the chromatography paper is in the solvent, but the solvent is below the start line. Then we are going to put a lid. We will put the lid to prevent the solvent from evaporating. Wait for the solvent to travel up the chromatography paper until it reaches near the top of the paper. But make sure that it doesn't reach the extreme top. We should stop the experiment before it reaches the extreme top. Mark the solvent front up until where the solvent has traveled, and try the chromatography paper after marking the solvent front. The measurements that we need to do are, we need to measure the distance between start line and the center of the spot, and measure the distance between the start line and the solvent front. Then we can use these two values to calculate the RF value. Two students investigated a dye in a food coloring using paper chromatography. Each student did the investigation differently. The RF values they determined for the same dye were different. How did the student investigation differ? The students used different length of paper. Length of paper does not change RF value. Different period of time is used. Even the different period of time will produce different distances, but the ratio remains the same. Different size of beaker used. Beaker does not affect the RF value, so different solvent can have different solubilities of that particular solute or the substance being tested, so they will give different results. Paper chromatography involves stationary phase. What is the stationary phase in paper chromatography? Paper chromatography has a stationary phase which refers to the phase that is unable to move, which in this case is the paper. Guys, that's all for this particular question paper. Thank you for watching the video. Guys, if you haven't subscribed to the channel, please subscribe. And question paper like this, we will try and upload as many as possible. If you have any question papers in mind that you want us to upload, let us know in the comments. And if you have any feedback that you want to give to us, please let us know as well. Guys, I'm located in DIP, near GIP Metro, in Dubai Investment Park. If you are looking for, group tuitions, or if you are looking for in particular home tuitions or tuition at my place, you can contact me through my email. So guys, best of luck for your exam. Thank you. See you in the next video.